Hello and welcome to What's Up With That, the series that demystifies all things Chrome. I'm your host, Sharon, and today we're talking about building Chrome. How do you go from a bunch of files on your computer to running a browser? What are all the steps involved? Our special guest today is Nico. He's responsible for making Ninja, the Chrome default build system, and he's worked on Clang and all sorts of areas of the Chrome build. If you don't know what some of those things are, don't worry, we'll get into it. Welcome, Nico.
Hello, Sharon, and hello, Internet.
Hello. We have lots to cover, so let's get right into it. If I want to build Chrome, at a really quick overview, what are all the steps that I need to do?
That's very easy. First, you download depot tools and add that to your path. Then you run fetch chromium. Then you do type cd source, run gclient sync, gngen out gn, and ninja-c out gn chrome. And that's it.
Wow, sounds so easy. All right, we can knock that out. See you guys next time. Okay, all right, let's take it from the start then and go over in more detail what some of those things are. So the first thing you mentioned is depot tools. What is that?
Depot tools is just a collection of random utilities for like back in the day for managing Subversion repositories. Nowadays for pulling things from Git. It contains Ninja and GN. Just adds a bunch of stuff to your path that you need for working on Chrome.
Okay, is this a Chrome specific thing or is this used elsewhere too?
In theory, it's fairly flexible. In practice, I think it's mostly used by Chromium projects.
Okay, all right. And there you mentioned Ninja and GN. And for people, I think most people who are watching this have built Chrome at some point. But what is the difference between Ninja and GN? Because you have your build files, which are generally called BUILD.gn, and then you run a command that has Ninja in it. So are those the same thing? Are those related?
Yes, so GN is short for Generate Ninja. So Ninja is a build system. It's like similar to Make. It basically gets a list of source files and a list of build outputs. And then when you run Ninja, Ninja figures out which build steps do I have to run, and then it runs them. So it's kind of like Make, but simpler and faster. And then GN, and Ninja doesn't have like any conditionals or anything. So GN is like just a build, like it describes the build. And then it generates Ninja files. Okay. So if you want to do like add these files only if you're building for Windows, this is something you can do, say in GN, but then it only like generates like a Windows-specific Ninja file.
All right. And in terms of, when you mention OS, so there's a couple places that you can specify different arguments for how you build Chrome. So you have your gclient sync. Your gclient file, and then you have a separate args.gn. And in both of these places, you can specify different arguments. And for example, the operating system you use, that can be specified in both places. There's an OS option in both. So what is the purpose of the gclient file, and what is the purpose of the args.gn file?
Yes, so gclient like reads this deps file that is at the root of the directory. And the deps file basically specifies dependencies that Chrome pulls in. It's kind of similar to Git submodules, but it predates Git. So we don't use Git submodules, also for other reasons. So if you run gclient sync, that reads the deps file at the Chrome root, and that downloads like a couple hundred repositories that Chrome depends on. And then it executes a bunch of so-called hooks, which are just Python scripts, which also download a bunch of more stuff. And the hooks and the dependencies are operating system dependent. So gclient needs to know the operating system. But the build also needs to know the operating system. And GN args are basically things that are needed like for the build. So the OS is something that's needed in both places, but many GN args gclient doesn't need to know about. For example, if we enable dchecks or no, like Peter discussed a few episodes ago, that's a GN only thing.
Mm-hmm. All right, that sounds good. So, let's see. When you run Chrome and you say you build Chrome, right? A typical example of a command to do that would be, say, autoninja-c /default content, right? And let's just go through each part of that and say what each of those things is doing and what happens there. Right? Because I think that's just an example, like from one of the starter docs. That's just a copy and paste command that they give you. So Auto Ninja seems like it's based on Ninja. What is the auto they're doing for us?
Yeah, so Auto Ninja is also like one of the things that's just in depot tools. It's a very or used to be a very thin wrapper around Ninja. Now it's like maybe a little thicker, but it's optional. Like you don't have to use Auto Ninja if you don't want to. But what it does is basically like it helps. So Chrome contains a lot of code. So we have this system called Goma, which can run all the C++ compilations in a remote data center. And if you do use the system, then you want to build with a very high build parallelism. You want to say -J 1000 or what, and run like 1,000 build processes in parallel. But if you're building locally, you don't want to do that. So what Auto Ninja basically does, it looks at your args.gn file, sees if you have enabled Goma, and if so, it runs Ninja with many processes, and else it runs it with just like one process per core or something like that. So that's originally all that Auto Ninja does. Nowadays, I think it also uploads a bunch of stuff. But you can just run which Auto Ninja, and that prints some path, and you can just open that in your editor and read it. I think it's still short enough to fairly quickly figure out what it does.
Okay. What does -C do? Because I think I've been using that this whole time because I copy and pasted it from somewhere, and I've just always had it.
It says it changes the current directory while Ninja runs. It's like in make. So it basically says change the current directory to out/gn or whatever your build directory is, and then run the build from there. So for Chrome, the build always the current directory during the build is always the build directory.
Okay.
And then Ninja looks for a file called build.ninja in the current directory. So gn writes build.ninja to out/gn or whatever your build directory is. And then Ninja finds it there and reads it and does its thing.
All right. So the next part of this would be out/default or out/something else. So what are out directories and how do we make use of them?
An out directory, it's just a build directory. That's where all the build artifacts go to, all the generated object files, executables, random things that are generated during the build. So it can be any directory, really. You can make up any directory name that you like. You can build your Chrome in, fluffy/kitten or whatever. But I think most people use out just because it's in the global.gitignore file already. Then you want to use something that's 2 directories deep so that the path from the build directory to the source is always ../... And that makes sure that this is deterministic. We try to have a so-called deterministic build where you get exactly the same binary when you build Chrome at the same revision, independent of the host machine, more or less. And the path from the build directory to the source file is something that goes into debug info. So if you want to have the same build output as everyone else, you want a build directory path that's 2 directories deep. And the names of those 2 directories doesn't really matter. So what some people do is they use out/debug for their debug builds and out/release for their release builds.
Right.
But it's really
other
up to
common ones are ASAN is a common one, different
right.
OSs. Right. So you mentioned having a deterministic build, and assuming you're on the same version of Chrome at the same checkout tip of tree or whatever as someone else, I would have expected that all of the builds are just deterministic, but maybe that's because of work that people like you and the build team have done. But what are things that could cause that to be non-deterministic? Because you have all the same files. Where is the actual non-determinism coming from? Or is it just different configurations and setups you have on your local machine?
Yeah, that's a great question. I always thought this should be very easy to, but turns out it mostly isn't. We wrote a very long blog post that we can link to from the show notes about this. But there's many things that can go wrong. For example, in C++, there's the preprocessor macro under date, which embeds the current date into the build output. So if you do that, then you're time dependent already. By default, I think you end up with absolute paths to everything in debug information. So if your build is in /home/Sharon/blah, then that's already different from all the people who are not called Sharon. Then there's we run tools as part of the build that produce output, for example, the protobuf compiler or whatnot. And so if that binary iterates over some map, some hash map, and that doesn't have deterministic iteration order, then the output might be different. And there's a long list of things. Like making the build deterministic was a very big project, and there's still like a few open things.
Okay, cool. So I guess it's not like true non-determinism maybe, but there's enough factors that go into it that to a typical person interacting with it, it does.
Yeah, but there's also true non-determinism. Like every now and then when we update the compiler will like write different object files on every run just because the compiler internally like iterates about over some hash map. And then we have to complain upstream, and then they fix it.
Okay. Oh, wow. Okay. That's very cool. Well, thank you for dealing with this kind of stuff so people like us don't have to worry about it. Okay. And the last part of our typical build thing is content. So what is content in this context? If you want to learn about content more in general, check out episode 3. But in this case, what does that mean?
It's just a build target. So I think like people, at least I usually like build some executable. Like I usually build, I don't know, like base unit tests or unit under tests or Chrome or content shell or what. And it's just, so in the Ninja files, there's basically like there's many lines that go like, if you want to build this file, you need to like have these inputs and then run this command. If you want to build this file, instead you need these other files need to run this other command. So, for example, if you want to build base unit tests, you need a couple thousand object files, and then you need to run the linkers, what's in there. And so, if you tell Ninja, like the last thing you give it, it's basically it tells Ninja like what do you want to build. So, if you say Ninja-c out/gn content shell or what, then Ninja is like, let's look at the line that says content shell, and then it checks I need these files. So it builds like all the prerequisites, which like usually means compiling a whole bunch of files. And then it runs the like final command and runs the linker. So Ninja basically decides like what it needs to do, and then invokes other commands to do the actual work.
Okay, makes sense. So say I built the target Chrome, which is the one that actually is an executable, and that's what, if you run that, the browser is built from it. So say I've built the Chrome build target. How do I run that now?
Well, it's written. So normally the thing you give to Ninja is like actually a file name, and the -c set change current directory. So if you say -c out/release Chrome, then this creates the file out/release/Chrome. Like it just creates that file in the out directory. So to run that, you just run out/release/Chrome, and hopefully it'll start up and work.
Great, sounds so easy. So you mentioned earlier something called Goma, which had remote data centers and stuff. Is this something that's available to people who don't work at Google, or is this one of the Google specific things? Because I think so far everything mentioned is anyone, anywhere can do all this. Is that the case with Goma also?
Yeah, for the other things, so Ninja is actually like something that started in Chrome land, but that's been like fairly widely adopted across the world. Like that's used by many projects. But yeah, Goma, I think like it's kind of like distcc, like it's a distributed compiler thing. I think the source code for both the client and the server are open source, and we can link to that. But the access to the service, I think, isn't public. So you either have to work at Google or at a like partner company. I think we hand out access to a few partners, and as far as I know, there's a few independent re-implementations of the protocol. So other people also use something like Goma, but as far as I know, these other services also aren't public.
All right. Yeah, because I think one of the main things is, as someone who did an internship on Chrome, after I was like, I'll finish some of these like remaining to-do items like once I go back to school, right? And then I started to build Chrome on my laptop, just like a decent laptop, but still a laptop. And I was like, no, I guess I won't be doing that.
No, it's doable. You just need to be like patient and strategic. Like I used to do that every now and then. You have to like start the build at night, and then when you get up, it's done. And if you only change like 1 or 2 CC files, it's reasonably fast. It's just full builds take a very long time.
Yeah, well, there was enough stuff going on that I was like, okay, we maybe won't do this. Right. Going back to another thing you mentioned is the compiler and Clang. So can you tell us a bit more about Clang and how compiling fits into the build process?
Yeah, sure. I mean, compiling just means like almost all of Chrome currently is written in C++, and compiling just means like taking a CC file, like a C++ file, and turning that into an object file. And there are like a whole bunch of C++ compilers. And back in the day, we used to use like many different C++ compilers, and they're all like slightly different. So that was a little bit painful. And then the C++ language started changing more frequently, like with C++ 11, 14, 17, 20, and so on. And so that was like a huge drain on productivity. Like updating compilers was like always like a like year long project, and we had to update like 7 different compilers, like one on Android, iOS, Windows, Mac OS, Android, Fuchsia, and whatnot. So over time, we moved from using basically like kind of like the system compiler to using a hermetically built Clang that we download as a gclient deps hook. So when you run gclient sync, that downloads a pre-built Clang binary. And we use that Clang binary to build Chrome on all operating systems. So if one file like builds for you on your OS, then chances are it'll build on all the other OSs because it's built by the same compiler. And that also enables things like cross-build. So you can build Chrome for Windows on Linux if you want to, because your compiler is right there.
Oh, cool. All right. I didn't know that. Is there any reason historically that Clang beat out these other compilers as the compiler of choice?
Yes. So it's basically like I think when we looked at this, so Clang is basically kind of like the native compiler on Mac OS and iOS, and GCC is kind of like the system compiler on Linux, I suppose. But Clang has always had like very good GCC compatibility, and then on Windows the default choice is kind of like Visual Studio. And we still want to link like against the normal Microsoft library, so we need a compiler that's ABI compatible with the Microsoft ABI, and GCC couldn't do that. And Clang also couldn't do that, but we thought like if we teach Clang to do that, then Clang basically can like target all the operating systems we care about. And so we made Clang work on Windows, like also with others, but there was like a team like funded by Chrome that worked on that for a few years. And also Clang has like pretty good tooling interface. So for code search, we also use Clang. So we now use the same like code to like compile Chrome and to index Chrome for code search.
Cool. Didn't know that either. So very interesting. Okay. We're just going to keep going back, and as you mentioned more things, we'll cover that and then go back to something you previously mentioned. So next on the list is gclient sync. So I think for everyone who's ever worked on Chrome ever, especially at the start, you know, you're like, I'll build Chrome. You build your target and you get these weird errors and you look at it and you think, oh, this is in some random weird spot that I definitely didn't change. What's going on? You ask a senior team member and they say to you, did you run gclient sync? And you're like, oh, I did not. And then you run it and suddenly things are okay. So what else is going? You mentioned a couple of things that happen. So what exactly does gclient sync do?
Yeah, so there's this file at the source root called deps, DEPS, all capital letters. And when you update, like if you git pull the Chrome repository, then that also updates that deps file. And then this deps file contains a long list of revisions of like dependent projects. And then when you run gclient sync, it basically syncs all these other Git repositories that are mentioned in the deps file. And after that, it runs so-called hooks, which like do things like download a new Clang compiler and download a bunch of other binaries from something called CIPD, for example, GN. But yeah, like it basically makes sure that like all the dependencies that are in Chrome but that aren't in the Chrome repository are also up to date, is what it does.
Okay. Do you have a rough ballpark guess of how many dependencies that includes?
It's operating system dependent. I think on Android we have way more, but like it's on the order of 200. I were like 150 to 250.
Sounds like a lot. Very cool. Okay. In terms of, speaking of, you know, other dependencies, one of the top level directories in Chrome is third party. And that seems like in the same kind of direction. So how does stuff in third party work in terms of building? Can you just build them as targets? What kind of stuff is in there? what can you and can you not build. Like, for example, Blink is one of the things in third party, and lots of people, that's a big part of it, right? But a lot of things in there are less active and probably less big of a part of Chrome. So does third party just build like anything else, or what's different about it?
And that's a great question. So Blink being in third party is like a bit of an historical artifact. Like most things, like almost all of the things in third party is basically code that's like third party code. That's code that we didn't write ourselves. And Chrome's secret mission is to depend on every other library out there in the world. Now, like we depend on things like libpng for reading PNG files, libjpeg for reading, or libjpeg turbo these days, I guess, for reading JPEG files, libxml for reading XML, and so on. And well, yeah, that's like many dependencies. I won't list them all. And some of these third-party dependencies are just listed in the deps file that we talked about. And so they basically, like when gclient sync runs, it pulls the code from some Git repository that contains the third-party code and puts it into your source tree. And for other third-party code, we like actually check in the code into the Chrome main repository instead of depsing it in. There are trade-offs like which approach to choose. We do both from time to time. But yeah, like almost no third-party dependency has like a GN file upstream. So usually what you do is like you have to write your own build.gn file for the third-party dependency you want to add. And then after that, it's like fairly normal. So for library, if you want to add a dependency on like libfoo, usually what we do is like you create third-party libfoo and you put build.gn in there, and then you add a deps entry that syncs the actual code to a third-party libfoo source or something. Yes.
All right, sounds good. Again, you mentioned build.gn files, and that's, as expected, a big part of how building works, and that's probably the part that most people have interacted more with, right? Outside of just actually running whatever command it is to build Chrome, because if you create, delete, rename any files, you have to update it in some build.gn file. So can you walk us through the different things contained in a build.gn file? What are all the different parts?
Sure. So there's like a great presentation by Brett who wrote GN that we can link to, but in a summary, it's like build.gn contains build targets, and the build target normally is like doesn't have to be, but usually it's like a list of CC files that belong together and that either like make up a static library or a shared library or an executable. So those are like the main target types for CC code. But then you can also have like custom build actions that run just like arbitrary Python code, which, for example, if you compile protobuf proto files into CC and H into C++ and header files, then we basically have a Python script that runs proto-C, the proto compiler, to produce those. And so in that case, the action generates C++ files, and then those get built. And but yeah, the simple answer is like libraries or executables.
Okay. One part of GN files that has caused me personally some confusion and difficulty, which I think is maybe depending on the part of Chrome you work on less of an issue, is deps. So you have deps in your GN files, and there's also something called external deps, and then you have separate deps files that are just called capital DEPS.
Yes, that's like some redundant. Like that's again, I guess for historical reasons. So in gclient deps just means to build this target, you first have to build these other targets. Like this target depends, like uses this other code. And in different contexts, it kind of means different things. So for example, if an executable depends on some other target, then when that executable is linked, that other target is also linked in. For example, if base unit tests depends on like the base library, which in a normal build is a static library, like in a normal build, like in a release build by default is a static library. And so if base unit tests is built, it first like creates a static library and then links to it. And then base itself might depend on a bunch of third-party things, libraries, which means when base unit tests is linked, it links base, but then it also links against base's dependencies. So that's like one meaning of deps. Another meaning, like these capital deps files, that's completely distinct, has nothing to do with GN, I'm sad to say, and that's just for enforcing layering those predate GN, and they are kind of like for enforcing layering at a fairly coarse level. They say code in this directory may include code from this other directory, but not from this third directory. For example, a third like Blink must not may include stuff from base, but must not include anything from, I don't know, like the Chrome layer or something.
Right, the classic content Chrome layering, where
right,
Chrome
I think there's
content,
right, and there's like a step called check deps, and that checks the capital deps files.
Okay, yeah, because before I worked on some Fuchsia stuff, and because we're adding a lot of new things, you're messing around with different depths and stuff a lot more than I think if you work in a typical part. Like now I mostly just work within content. Unlikely that you're, changing any dependencies. But that was always a bit unclear because for the most part, the targets have very similar names. Not exactly the same, but very similar. And if you miss one, you get all these weird errors, and it was, generally quite confusing. But
yeah, that's pretty confusing. Like one thing of the capital deps things that they can do that the GN deps can't is if someone adds a dep on your library and they add an entry to their deps file, that means that now at code review time, you need to approve that they depend on you. And that's not something we can do at the GN level. And the advantage there is like, I don't know, if you have like some library and then 50 teams start depending on it without telling you, and now you're on the hook for like keeping all these 50 things working. And with this system, you at least have to approve like every time like someone adds a dependency on you, you have to say this is fine with me.
Right.
Or you can say, oh, actually, this is like we don't want this to be used by anyone else.
Is there an ideal state where we don't have these depth files and maybe that functionality is built into the build.gn files, or is it something that's probably going to be sticking around for a while?
It's a great question. I don't know. It's it seems weird, right? It's redundant. So it's. I think the current system isn't ideal, but it's also like not horrible enough that we have to fix it immediately. So maybe one day we'll get around to it.
Yeah, I think I've mostly just worked on Chrome, so I've gotten pretty used to it. But a common complaint is people who work in Google internal things or other kind of bigger, the main build system of whatever company they work on, they come to Chrome and they're like, oh, everything's so confusing. But if you just gotta get used to it. But
right, I think like if you're confused by anything, it's great if you like come to us and complain, because you kind of become blind to these problems, right? I've been doing this for a long time. I'm used to all the foot guns. I know how to dodge them, and so if you're like confused by anything, please tell me personally, and then like if enough people complain about something, maybe we'll fix it.
All right. Yeah, that's what you said. If the outcome of that, we'll see how that goes. We'll see how many complaints you suddenly get. Right. Okay. So another thing I was interested in is right now there's a lot of work around Rust, right? Getting more Rust things, introducing that, memory safety, that's good, we like it. What is involved from a build perspective for getting a whole other language into Chrome and into the build? Because we have most things C++, there's some Java in all of the Android stuff, and in some areas you'll see a file name, and then you'll see file name underscore, and then all the different operating systems, right? And most of those are some version of C++. The Mac ones are .mm, and you have Java ones for Android. But if you want to add an entirely different language and still be able to build Chrome, at a high level, what goes into that?
Yeah, there's also some Swift on iOS. It's many different things. So at first you have to teach GN how to generate Ninja files for that language. So when like a CC file is built, then basically the compiler writes out a file that says, here are all the header files I depend on. So if one of them gets touched, the compiler or Ninja knows how to rebuild those. So you need to figure out how the Rust compiler or the Swift compiler track dependencies. You need to get that information out of the compiler into the build system somehow. And C++ is like fairly easy to build as it's like on a per file basis. I think most languages are more like on a module or package base where you build a few files like as a unit. then you might want to think about like how can I make this work with Goma so that the compilation can work remotely instead of locally. So that's the build system part. Then also, especially for Rust, like we want to use this for like some performance critical things. So it needs to be very fast. And we used like a bunch of toolchain optimization techniques to make Chrome very fast with 3-letter acronyms such as PGO and LTO and whatnot. And LTO in particular, that means link time optimization. That means the C++ or the Rust code is compiled in something called bitcode. And then all the bitcode files at link time are analyzed together, so you can do like cross-file inlining and whatnot. And for that work, the bitcodes, like all the bitcode versions, need to be compatible, which means Clang and Rust need to be built against the same version of LLVM, which is like some internal compiler machinery that defines the bitcode. So that means you kind of have to, like, if you want to do cross-language LTO, you have to update your C++ compiler and your Rust compiler at the same time. And you have to build them at the same time. And when you update your LVM revision, it must break neither the C++ compiler nor the Rust compiler. Then you kind of want to build the Rust library from source, so you have like bitcode for all of that. So it's fairly involved. But yeah, we've been like doing a lot of work on that. Like not me, but other people.
Right. Sounds hard. And what does LTO stand for, since you used it?
For link time optimization.
All right.
And there's a blog post on the Chromium blog about this that we can link to in the show notes. That's has a fairly understandable explanation what this does.
Yeah. All right. That sounds good. So linking, that was my next question. As you build stuff, you sort out all of your just compile errors, right? You got all your spelling mistakes out. The next type of error you might get is linking error. So can you tell us a bit more about linking in general and how that fits into the build process?
I mean, linking, like for C++, the compiler basically produces one object file for every CC file, and then the linker takes like about 50,000 to 100,000 object files and produces a single executable. And every object file has like a list of functions that are defined in that object file and a list of functions that are undefined in that object file that it calls that are like needed from elsewhere. And then the linker basically makes like one long list of all the functions it finds, and at the end, like all of them should be defined, and all the non-inline ones should be defined in exactly one object file. And if that doesn't happen, then it like emits an error, and else it emits a binary. And the linker is kind of interesting, like because like the only thing you really care about is that it does its job very quickly, but it has to read through like gigabytes of data and before it writes the executable. And currently we use a linker called LLD, which was also written by people on the Chrome team and which is also like fairly popular outside of Chrome nowadays. And so we wrote like our own like ELF linker, and which is the file format used on Linux and Android, and our own COF linker, which is the file system used on Windows, and our own Mac O linker, which is the file system on Apple, like macOS and iOS. And our linkers are like way faster than the things that they replace. Like on Windows, we were like 10 times faster than the Windows linker, and on Mac, we're like 4 times faster than the system linker and whatnot. And the other linker vendors have like caught up a little bit, but I feel like Chrome has really like advanced the state and performance of linking binaries across the industry, which I think is really cool.
Yeah, that is really cool. And in a kind of similar vein to the different OSs and all that kind of stuff is 32 versus 64-bit. There's some stuff happening. I've seen people talk about it. It seems pretty important. Can you just tell us a bit more about this in general?
I guess like most processors sold in the last decade or so are 64-bit. So I think on some platforms we only support 64-bit binaries. Like I mean the bitness just means like how wide is a pointer, and it has like some implications on which instructions can the compiler use. But it's fairly transparent too. I think at the C++ level, like you don't have to worry about it all that much. On macOS, we only support 64-bit builds, same on iOS. On Windows, we still have 32-bit and 64-bit builds. on Linux, we don't publicly support 32-bit, but I think some people like try to build it. But it's like really on Windows where you have both 32-bit and 64-bit builds. But the default bitness is 64-bit, and you can say, if you say target CPU equals x86, I think, in your args.gn, then you get a 32-bit build. But it should be like fairly transparent to you as a developer, unless you write assembly.
How big of an effort would it be to get rid of 32-bit on Windows? Because Windows is probably the biggest Chrome using platform, and also there's a lot of versions out there, right? So
yeah, I think that the biggest platform is probably Android. But yeah, Android is also 32-bit ARM, at least on some devices at the moment. That's true. You don't know. I think we've looked into it and decided that we don't want to do that at the moment, but I don't know details.
Okay. And you mentioned ARM. So is there how much does the Chrome build team, are they concerned with the architecture of these processors? Is that something that at the level that you and the build team have to worry about, or is it far enough a few layers down that's
it's like something we have to worry about at the toolchain team. So we update this Clang compiler like every 2 weeks or so, which means we like pull in all like around 1,000 changes from upstream contributors that work on LVM, who are like spread across many companies, and we have to make sure this doesn't break Chrome like on 32-bit ARM, 64-bit ARM, 32-bit Intel, 64-bit Intel across 7 different operating systems. And so fairly frequently when we try to update Clang, tests start failing on, I don't know, like 32-bit Windows or on 64-bit iOS or like some like very specific configuration, and then we have to like go and debug and bisect and figure out what's going on and work with upstream to get that fixed. So yeah, that's something like we have to deal with at the toolchain team, but hopefully this hopefully like the normal Chrome developer is isolated from that for the most part.
I think so. It's not, if I weren't asking all these other questions, it's something that almost never crosses my mind, right? So that means you're all doing a very good job of that. Thank you very much. Much appreciated. And jumping way back, you mentioned earlier indexing the code base, code search. Mm-hmm. So I make a change, I submit it, I upload it. It eventually ends up in code search. So how does that process work? And what goes into indexing? Because before, when I was working on Fuchsia, all the Fuchsia code wasn't indexed. So you couldn't do the handy thing of clicking a thing and seeing what it was defined. You had to actually look it up. And once you got that, it was like, oh my gosh, so much better. So can you just tell us a bit more about that?
Yeah, sure. Process? Yeah. So Chrome has a pretty good code search feature at, I think, codesearch.chromium.org or cs.chromium.org. Basically, we have a bot that runs, I think, every 6 hours or so, like pulls the latest code, bundles it up, sends it to some indexer service that then also uses Clang to like analyze the code, like for C++. I think we also index Java. We probably don't index Rust yet, but eventually we will. And then it generates, like for every word, generates metadata that says this is a class, this is an identifier. And so if you click on it, like if you click on a function, you have the option of like jumping to the definition of the function, to the declaration, to all the calls, all the overrides, and so on. And that updates ideally like several times a day and is fairly up to date. And we built the index, I think, for most operating systems. So you can like see this is called like here on Linux, here on Windows, and whatnot.
Okay. Sounds good. Very useful stuff. And I don't know if this is part of the build team's jurisdiction, but when you are working on things locally, you have some Git commands, and then you have some Git CL commands. Mm-hmm. So the Git commands are your typical ones: Git pull, Git rebase, Git stash, that kind of thing. And then you have Git CL commands, which kind of relate more to your actual CL in Garrett. So Git CL upload, Git CL status, that'll show you all your local branches and if they have a Garrett change associated with them. So what's the difference between Git and Git CL commands?
Yeah, sure. Oh, sorry. So this is like basically a Git feature. If you call git foo, then Git looks for git-foo on your path. So you can add like arbitrary commands to Git if you want to. And gitcl is like just something that's in depot tools again. There's a git-cl in depot tools, and you can open that and see what it does, and it'll redirect to git_cl.py, I think, which is a fairly long and hairy Python script. But yeah, it's basically Gerrit integration, as you say. So you can use that to send try jobs, gitcl try. You can to upload, as you say, you can use gitcl issue to associate your current branch with a remote Gerrit review. Gitcl patch to like get a patch of Gerrit and patch it into your local thing. Gitcl web to open the current thing in a web browser. But yeah, gitcl is basically like, or gitcl help to see all the gitcl commands. Or yeah, if you ever change that touches like 1,000 files, you can run gitcl split and it'll upload 500 reviews. But that's usually like too granular, and I wouldn't recommend doing that. But but it's possible.
Right. Do you have a
Sorry.
commonly? Yep.
Sorry, there was the door just rang. Maybe you didn't hear it. Sorry.
All right, it's all good. Do you have a lesser known git or gitcl command that you use a lot, or
Well, I mean,
is your favorite?
It's not lesser known to me, so I wouldn't know. I don't know, like I use gitcl upload a lot.
Right, but well, you have to use gitcl upload, right?
I use gitcl try to send try jobs from my terminal, gitcl web to see what's going on, gitcl patch a lot to like patch stuff in locally. If I'm doing a code review and I want to like play with it, I patch it in, build it locally, and see how things are working.
Yeah, when I patch in a thing, I like go from the CL page on Gerrit and then click the download patch thing. But
even like gitcl patch -b and then some branch name, and then you just paste the Gerrit review URL.
Oh, cool.
So it's just Control L to focus the URL bar, Control C, L tab, gitcl patch -b blah, paste, enter, and then you have a local branch with the thing.
All right. Yeah, a lot of these things, once you learn about them, at first you're like, whoa, and then you use them, and then they're not less known to you, but you tell other people. Also, another one would be like gitcl archive, which will get rid of any local branches associated with a closed Gerrit branch. That's very handy too. So It's always fun to learn about things like that.
Are you like fairly tidy with your branches? How many open branches do you usually have?
I used to be more tidy, then I tried to do a cleanup thing that had more branches. I think right now I'm at around 20-something branches. I like having not very many. I think to some people that's a lot, to some people that's not very many. I mean, ideally I have like under 5, right? But
yeah, I don't know. I'm usually have like a couple 10 sometimes. Like I have a bunch of machines. I think on some of them it's over 100, but yeah, every now and then I run gitcl archive and it removes half of them, but
yes. All right, cool. Is there anything that we didn't cover so far that you would like to share? So things that maybe you get asked all the time, things that people could do better when it comes to build related things, like things that you can do that make the build better or don't make it worse, that kind of thing, or just anything else you would like to get out there.
Yeah, I guess one thing that's like maybe implicitly stated but currently not explicitly documented as far as I know, but I'm hoping to change that is, so Chrome tries to have a quiet build. Like if you build, there's like 0 build output except like that one Ninja line that's changing, right? While in other code bases, I think it's fairly common that there's like many screenfuls of warning that scroll by. And we very explicitly try not to do that, because if the build emits lots of warnings, then people like just learn to ignore warnings. So we think like something should either be like a serious problem that people need to know about, then it should be like an error, or it should be not interesting, then it should be just quiet. So if you add a build step that adds like a random script, the script shouldn't like print anything, like just like about progress shouldn't say doing this, doing this, doing this. It should either print something and say something's wrong and fail this build step, or not say anything. So that's one thing.
That's true. Like, you only really get a bunch of terminal output if you have like a compile or a linker error or whatever. Right. I hadn't ever considered that. If you build something and it works, you get very few lines of output, and I hadn't ever thought that was intentional before. But you're right in that if it was a ton, you would just not look at any of it. So yeah, that's very cool.
Yeah, and on that same note, we don't do deprecation warnings because we don't do any warnings. So people people like deprecating things, but people don't like tidying up like calls to deprecated functions. So if you want to deprecate something in Chrome, the idea is basically like you remove all callers and then you remove the deprecated thing, and we don't allow you to say, like, to add a warning that like tells everyone, hey, like, please everyone remove your calls. The onus is kind of on the person who wants to deprecate something instead of punting that to everyone else.
Yeah, I mean, the thing I was working on is a deprecating thing, so we're removing callers, which is why I have so many branches. But I've also seen pre-submit warnings for if you include something deprecated. So, oh yeah, there's pre-submit too. Okay, we'll get into that also. Tell us more about all of this.
About pre-submits, yeah, pre-submits is pre-submits are terrible is the short summary. So if you run like git-cl pre-submit, it'll look at a file called presubmit.py, I think in the current directory, and maybe in all the directories of files of directories that contain files you touched or something like that. But you can like just open the top level presubmit.py file, and there's like a couple thousand lines of Python where basically everyone can add anything they want without much oversight. So it's a fairly long, at least historically that used to be the case. I don't know if that's still the case nowadays. But yeah, it's basically like a long list of things that random people thought are good if they are like presubmits are something that are like run before you upload also, like implicitly, and so you're supposed to clean them up, and it warns about like many useful things. For example, nowadays we require most code to be auto formatted so that people don't argue about where semicolons should go or something silly like that. So one of the things it checks is did you run git-cl format, which runs, I guess, Clang format for C++ code and like a bunch of custom Python scripts for other files. But it's also, it's like presubmits have grown organically, and there isn't like, they're kind of unowned and they're very, very slow. And I think like some people have tried to improve them recently and they're better than they used to be, but I don't love presubmits, I guess is the summary. But yeah, it's another thing to check invariants that we would like to be true about our code base.
Yeah, I mean, I think, spelling is something I think it also checks.
What checks
so
spelling?
Or maybe that's a separate bot in Garrett. It's
there's like there's this thing called what's its name?
Tricium,
Tricium, right? Tricium is something that adds comments to your, like, automatically adds comments to your change list when you upload it. And Tricium can do spelling correction, but it can also, like, it runs something called Clang tidy, which is basically a static analysis engine, which has like quite a few false positives. So sometimes it complains about something but it's actually incorrect. And so we don't put that like into the compiler itself. So we've added like a whole bunch of warnings to the compiler for things that we think are like fairly buggy. But Clang tidy is, but these warnings have to be, they have to have a very low false positive rate. Like if they complain, they should almost always be right. But sometimes, like for static analysis, it's hard to be right. Like you can say this might be wrong, please be sure, but this is not something the compiler can say. So we have this other system called Clang tidy, which also adds a comment to your C++ code where it says, well, maybe this should be like a reference instead of a copy and things like that.
Yeah, and I think I've seen it like. It checks for unused variables and other, there's been useful stuff that's come from comments from there, so definitely. All right, very cool. So if people are interested in all this build infra-y kind of stuff and they want to get more into it, what can they do?
We have the public build@chromium.org mailing list. That's very low volume, but if you like want to reach out, you can send an email there, and a few of us will see your email and interact with you. And there's also, I think, the tag build on CR bugs, so you can just like look for build bugs and fix all our bugs for us. That'd be cool. And if there's anything specific, like just talk to like local owners, or if there's like this is like just something you're generally interested in, you're looking for a project, you can like talk to me, and I probably have like a long list of, like I do have a long list of somewhat beginner-friendly projects that people could help out with, I guess.
Yeah, I mean, I think being able to, if you're looking for a 20% kind of project or something else, but knowing how things actually get put together is always a good skill. And definitely applicable to other things. It's the kind of thing where, the more low-level knowledge you have, the more it works, it applies to things higher up, but not necessarily the other way around, right? So having that kind of understanding is definitely a good thing. All right. Any last things you'd like to mention or shout out, or cool things that you want people to know about?
I guess,
quickly, like, what is the future of the whole build thing? Like, what's the ideal situation if...
Ideally, it'll all be way faster, I guess, is the main thing, but... Yeah, I think build speed is a big problem, and I'm not sure we have the best handle on that. Like, we're working on many things, but not many, a bunch of things, but it's people keep adding all that much code. So so if you all could delete some code too, that would help us a lot. I mean, having supporting more languages is something we have to. This is something that's happening. Rust is happening. We are also on iOS also using Swift. Currently, we can't LTO Swift with the rest because that's on a different LVM version. There's this in C++, we keep upgrading C++ versions. So Peter Casting is working on moving us to C++ 20, and then 23 will happen, and so on. There's maybe C++ modules at some point, which may or may not help with build speed. Yeah, and there's a bunch of tech debt that we need to clean up, but that's not super interesting.
I don't know. I think people in Chrome in general are more interested and care about reducing tech debt than in general, right? A lot of people I know would be happy to just do tech debt cleanup things only, right? Unfortunately, it doesn't really work out for, job reasons. But a lot of people, I think, are interested, and I think in higher proportions than maybe other places.
It depends on the tech debt. Some of it might work out for job reasons, but yeah.
Yeah, I mean, some of it is easier than others too, right? Some of it is yeah. So, okay, well, go delete some code, go clean up some deprecated calls. All that.
Yeah, and I think finishing migrations is way harder than starting them. So finish more migrations and start fewer migrations. That'd be also cool.
All right. I am sure everyone listening will go and do that right away.
Yep,
and
I know.
Things will
they've
immediately be better.
They've just been waiting to hear that from me, and now they're yeah, right. That makes sense.
Yeah. All right. Well, you all heard it here first. Go do that. Things will be better, etc. So, all right. Well, thank you very much, Nico, for being here, answering all these questions. I learned a lot. A lot of this is stuff that, everyone who works on Chrome builds Chrome, right? But you can get by with a very minimal understanding of how these things are. You follow the intro to building Chrome doc, you copy the things, you're like, okay, this works. And then you just keep doing that until you have a problem. And depending on where you work, you might not have problems, right? So it's very easy to know very little about this, but obviously it's so important because if we didn't have any of this infrastructure, nothing would work. So one, I guess, thank you for doing all the stuff behind the scenes, determinism, OSs, all that, making it a lot easier for everyone else, but also thank you for sharing about it so people understand what's actually going on when they run the commands they do every day.
Sure, anytime. Thanks for having me. And it's good to hear that it's possible to work on Chrome without knowing much about the build, because that's kind of the goal, right? It should just work.
Yeah.
Sometimes it does.
Yeah. Well, thank you for all of it, and see you all next time.
Yeah, see you on the internet. Bye.
Okay. So we will stop recording.
Time for the second take.
Let's do that. Yeah, all over again. I will stop recording.